All right, 40. We've got this function from 0 to pi, given tangents that, solve that. All right, so if this is equal to 0, we can factor out an e to the 2x for sure. And that's it, actually. So root 3 sine x plus cosine x. So e to the 2x is never 0 because it's exponential. So there's no solution for that, but we can have this bit equal to 0 and then subtract cosine, divide by it, so divide by just cosine, so we still have -1 on that side, and then sine over cosine is tangent, and we're going to have -1 over root 3. So we want the right side of the finger down to be 1 and the left side to be 3, because this is going to be 1/2 divided by root 3 over 2. Okay, now, so that's happening at the pi over 6 finger, and tangent is negative here and here in those quadrants. Actually, it's going to be more like this because it's pi over 6 and pi over 6 here. All right, so now it's in between 0 and pi only. So we only have 5 pi over 6, pi minus pi over 6. So 5 pi over 6. All right, so first we're going to take the square root. Okay, plus or minus 1. Then we need to change the interval. So we're multiplying everything by 2, so -pi to pi. And tangent is -1. Remember, you want the right side to be the same as the left side, because that's root 2 over 2 divided by root 2 over 2, so 1. Now, that's at the pi over 4 finger, and we want it plus or minus, so it's going to be here and here, whatever. Okay, so pi over 4, pi over 4, pi over 4, pi over 4. All right, now we're in between -pi and pi, so we're going to go the 0 to -pi first. Okay, so that's happening. So 2 theta is going to be -pi over 4. And basically, this is -pi, so we need to add pi over 4. So that's -3 pi over 4. And it's just going to be the positive signs for 0 to pi. So it's going to be at pi over 4 and pi minus pi over 4. So 3 pi over 4. So then we divide by 2, so we have -pi over 8, -3 pi over 8, and I'm just going to do plus or minus because it'll be the same. All right, this one we have to do some identities. So we have 2 sine x cosine x, and let's subtract 2 root 3 cosine squared x equal to 0. Now we can factor out at least a 2 cosine x, and that's going to be sine x minus root 3 cosine x. Now we have 2 cosine x is 0, so cosine x is 0, or sine x minus root 3 cosine x is 0, so sine x is root 3 cosine x. Dividing by cosine, we get tangent is root 3. All right, so cosine is 0 here and here. All right. So, and we didn't need to change domain because we made it look like this. So we're in between 0 and 2 pi. So we're going to be at pi over 2 and 3 pi over 2 for this one. Now, tangent, we want the right side over the left, right side to be 3 up in the left side because this is root 3 over 2 sine over 1 over 2 cosine. Now, tangent is positive in the first and fourth quadrants, and that's at the pi over 3 finger, 60 degrees. This is also pi over 3, so we have x is pi over 3, or pi plus pi over 3, which is 4 pi over 3. So for this one, express in terms of sine. So the relationship between cosine squared and sine squared is the sine squared plus cosine squared equals 1. So we're going to have 2, 1 minus sine squared, x. Okay, cosine squared plus sine squared is 1. Okay, plus sine, and that's that. So for B, solve this equation equals 2. So we're going to have this thing equal to 2. Now, so we'll expand the bracket, 2 minus 2 sine squared x plus sine x equals 2. I'm going to get everything to the right side. So we're going to have 2 sine squared x. Actually, those go away. Minus sine x. And factor out a sine. So we have sine x is 0. And 2 sine x minus 1 is 0. So sine x is 1/2. Now, sine is 0 here, and we're from 0 to pi. So we're at 0 and pi for those answers. And sine x is 1/2 at pi over 6. So we're here and here. So that's going to be pi over 6 and pi minus pi over 6, 5 pi over 6. All right, you've got this trig equation, write this in the form f at x equals 0, where, okay, so they want it in terms of cosine, first of all. So we'll use the fact that sine squared x plus cosine squared x is 1. So sine is 1 minus cosine squared x, or sine squared is, and that is equal to 1 plus cosine x. If we want this equal to 0, we'll expand. And we'll get it equal to 0. So 2 cosine squared x plus cosine x, and then minusing 2, we have minus 1. So that's A. So now factorize. So we're going to have 2 cosine x and 1, and cosine x and 1, because we need this times this to be this, and this times this to be this. All right, so we need to figure out the signs. We need a positive 1 in the middle, so we need this to be positive and this to be negative. And now we want to solve it, so we've got, for this one, we've got cosine x equals 1/2, and for this one, we have cosine x equals negative 1. So, from 0 to 360, cosine is 1/2 at the 60-degree finger. So we're from 0 to 360, and it's cosine and it's positive, so we have here and here. So we have x is 60 degrees and 360 minus 60, so 300. And cosine's negative 1 only here at 180 degrees. Okay, so for this one, we have a cosine 2x, and we have a cosine squared, and we have a sine squared. So we need to get those all probably to be what they have in common is cosine squared. Okay, so cosine 2x, that's in your formula booklet. It's 2 cosine squared x minus 1. And then we have minus 3 cosine x minus 3 minus cosine squared x, and sine squared plus cosine squared is 1. So we can have sine squared is 1 minus cosine squared. We need to get all the like terms together and equal to 0. So we're going to have 2 cosine squared minus cosine squared, which is cosine squared, plus cosine squared, so 2 cosine squared. Then we're going to have minus 3 cosine x, and then we're going to have negative 1, minus 3, negative 4, minus 1, minus 5. So now we can factor. So what multiplies to 2 cosine squared is 2 cosine x and cosine x. And we need to put the factors of 5, which is prime, 1 and 5, so that the outsides plus the insides add to negative 3. So it has to be here and here. And we need a negative 5 cosine x plus 2 cosine x. So negative 5 plus 2. Now, cosine x for this bracket is going to equal 5 over 2. Now, you all know that cosine goes in between negative 1 and 1. That's on the unit circle. Top value is negative 1, and bottom value is negative 1. So this is no solution here. But here, this cosine x equals negative 1. That's happening here at pi. And that's our only answer. All right, show this equals this. So, yeah, I mean, we could probably just do one side, because we can do the cosine 2 theta to be 1 minus 2 sine squared theta plus 5 sine theta. And then we have 4 minus 1 plus 2 sine squared theta plus 5 sine theta. And then we'll put it just in order. And 4 minus 1 is 3. So, okay. All right. So B, solve that equation. This is typical how they write that stuff. So we know what it's equal to, and we need to factor. So 2 sine theta here, sine theta here, because that's what multiplies to 2 sine squared. And then we need 3 and 1. So because it's same sign, because here 3 and 1, we've got 6 and 1. But it needs to be the same sign. So that's either going to be 7 or negative 7. So that's not it. So we need 3 here, 1 here, and they both have to be plus. So here we get sine theta is negative 3 over 2. This is outside, so there's no solution. Sine is at most 1 and at least negative 1. And here we have sine theta is negative 1, which is happening down here for that 0 to 2 pi interval. Okay, 47 without graphing calculator. So we're going to have 3 over 5 equals sine over cosine. 3 over 5 is the 0.6, and tangent x here. So we have x is tangent inverse 0.6. So it's 31 degrees. It's tangent, it's positive. So we've got here and here. So from 0 to 360, so we're going to have x is 31 degrees, or we have 180 plus 31, which is 211. All right, so now we have this. Okay, so we need to factor. Oops. So we have 3 sine x and sine x to multiply to the 3 sine squared x. And now factors of 6. So we've got 6 and 1. If we do 6 and 1, that's 18 and 1. That's not going to get to 11. If we have 1 and 6, that's 3 and 6. So that's either 9 or negative 9. 3. Yeah, I was going to say 9 or 3, but since it has to be the same sign because of the positive. Okay, so 1 and 6 isn't working. So we can do 2 and 3. So that's 6 and 3, 9. So 3 and 2. So, because 9 and 2 is 11. So same sign here, because it has to multiply to positive 6, and also this is negative 9 minus 2, so negative 11. All right, so we've got sine x is 2/3, and sine x is 3. This is well outside, so no solution for that one. If we take the sine inverse to get x by itself, we get that x is going to be 42, and this is from 0 to 180. It's sine, so we have here and here. So 42 is one of your answers, and also 180 minus 42, so 138. All right, write an expression in that form. So we need to change the sine squared to 1 minus cosine squared. Plus 4 cosine x. Distribute. So we're going to have negative 3 cosine squared x plus 4 cosine x plus 3. So that's A. B, find the two values of cosine that satisfy that equation. Okay, so we have this bit is this bit, okay? So negative 3, and I'm actually, well, I'll deal with it in a second. And then we are subtracting 4 equals 0. So I'm going to get, oh, it doesn't matter, does it? Because, yeah, this is with graphing calculator. So it's, yeah, whatever. Okay, so 3 cosine squared x minus 4 cosine x minus 1 plus 1 here. So we're going to have 3 cosine x and cosine x, and we're going to have 1 and 1. It needs to be positive, so it's the same sign, so it's going to be negative 3 minus 1. Okay, so that means we have cosine x here is 1/3, and cosine x is 1. So this one is straightforward. Cosine x is 1 here, so that is 0. X is 0. Oh, I see. Okay, so the two values of cosine x are, so for B, it's 1/3 and 1. It's this. And then it's saying solve. So this is what I'm doing. So 0 to 90. Okay, so cosine x is 1/3. We need to take the inverse cosine of 1/3. And that needs to be in degrees. Okay, so that ends up being 70.5, and we can just leave it like that because it's in this first quadrant between 0 and 90. So 0 and 70.5. All right, so solve the equations with graphing calculator. So we're just gonna do a graph. Okay, so for here, I put in cosine 3x into the first function, the blue one, and cosine 0.5x into the red one. Make sure it's in radians. And then from 0 to pi, so you can change your window settings from 0 to pi. And, okay. So really, this is going to be an intersection. Okay, so I should have done it, and I should have said that. Do a little bit outside. So do -1, and then just do pi plus 1-ish. Okay, I think this one will be outside, so be careful of that. So this one is clearly, the intersection is going to be 0. So 0, and we're just looking for the x's, so 0. And then we have 1.795. So for this one, it's x is 0, 1.80 to 3 significant figures, and then keep going along. What's up here? All right, we need this one. Intersection. That's 2.51. Oh, for goodness. Okay, that's fine. Sorry, I was looking at the wrong thing. And then menu, analyze graph, you'll see that this one over here is outside because pi is 3.14, so that's outside. So those are your 3 answers for that one. Okay, so for this one, oh, I put the wrong thing in first of all. So this needs to be a 3. But when you put sine squared, you need to put sine x into brackets and then square that whole thing, okay? And then minus 11 sine x plus 6. And we'll change it to, we'll push enter, change it to degrees. And we want to equal to 0. So if I just zoom out, because it's in between 0 and 180, so I guess I could just change it. No, sorry. So let's just do to 200, but outside. So here and here. We have zeros, okay? But you could have also put in function 2 as 0 and found the intersection. So we've got 41.8 for B. And then we have over here 138, okay? So 138.